Hello, Cara. You're right. How are you doing? Is this thing actually working? It is, yeah. Thanks for sending me all your uh, answers and stuff. They're really useful. Um, so I've gone through quite a lot of things what we need to work on. This video is about the equation of the line. So there's two kind of let's do graphs and trying to work out how graphs work. The main equation here is y equals mx plus c. Now in the exam, what they're going to ask you is they're going to ask you to match. They're going to give you an equation like, which will follow this, like y equals 2x plus 4. And then they'll show you some graphs, like this or this, that. And they'll say, which graph corresponds to this equation? Now, you need to know a few things before you look at this and go, oh, that's this, okay? You need to know what all these numbers mean. So let's look at m. M means the gradient. C means where the line crosses the y-axis. The y-axis being y, x, where it crosses here, yeah? So you've got this formula y equals 2x plus 4. I would say let's just, you know what the gradient is as well, don't you know? So the example, you got this 1, 2, 3, minus 1, minus 2. If say it crosses here, from here to 4, you look at the coordinates, so x equals minus 2, y equals 4. And so you've got 2 and 4 here. 2 goes into 4 twice. So what that's telling you is that whenever the line crosses x, here, it will always be twice as big in y. So that tells you the gradient is 2. Yeah. It's the same for, because the gradient, because the point at which the line crosses y will always be twice as big as the point at which it crosses x. So the gradient is 2. Same with like 3 and 6, 2. If it's the other way around, you can, you just divide it you divide x by y to get you the gradient, okay? So let's look at this again. Y equals 2x plus 4. This is telling you that the gradient's 2. So it means that it's that y is always the value of y is always twice as big as the value of x, and this is telling you where it crosses the y-axis. Yep. Well, I hope that makes sense. We're going to go on through the questions now. I mean, some of these graphs are also the things that in your exam you're having problems with. All right. This is me being very uncomfortable. I'm going to move myself a little bit. Hopefully you can see that. Oh, God, you can see that. Okay. So as you can see, we've got two things going on here. We've got a pink line and a green line. So we're going to try and work out the green line first. As you can see here, the green line cuts across. And can you see where it cuts across the y-axis? 0. So we're doing this. We can already fill out C, which is 0, because it cuts the y-axis 0. And to work out the gradient, it's really quite easy how we do this. You can draw it from here. You can do it from anywhere. You can go from 3, or say from 1, or whatever. It doesn't really matter. But 1, cut across it. So I draw up at 1 and see where that. So I draw it from the x-axis up to the line, and then from there I go 90 degrees and see where that corresponds to in the y-axis. In this example, x equals the coordinate 1, and on the y-axis it crosses 1. 1 divided by 1, 0, yeah? There's no gradient, so that means that wherever the line crosses x, it'll mean exactly the same. The gradient will be exactly the same on that side, so the gradient is 0. So 0x. So for the green axis, it's y equals 0x. So you can actually say y equals x. That's what that's telling you is that what that's telling you is that the line of the equation is telling you that y and x are exactly the same. Yeah, because they cut through it exactly half through. There's no gradient, and they go through the point of origin, which is here. Okay, so whenever you see like this thing where you see that y and x are exactly the same, it just means y equals x. Okay, there's no there's no difference between the y and the x. Yeah. All right, let's look at the pink one now. Pink one's a little bit different. So again, look, you can look at the C. Says where does the line cut across the y-axis? The y-axis is this one going along here. Yeah, you should know this already. So you can see it cuts across 1. So for this one, we can go y equals mx plus 1. Now we need to try and work out the gradient. You can use the same thing as we did last time. So you can see here that the the line cuts across x-axis at -1. So x equals -1, and it also cuts the y-axis at 1. Yeah. Hopefully that makes some sense. And so you divide x by y. So 1 divided by 1. There's no gradient again. Like the line crosses the x-axis at 1 and also crosses the y-axis as 1. So they're both exactly the same. So there's no gradient. It's like if you look at a mountain, it will be like a flat line. Yeah, there's no gradient at all. It's flat because the y-axis is 1 and x-axis is 1. So there's no differentiation. So that is 0. So all you get is y equals x plus 1. Yeah. One thing I would say is that this section here, in this section here, the gradient, if it is positive, it will go in this direction. If the gradient is negative, it will go in that direction. Okay, it will go that way. Okay, so just make sure the gradient, if you have a positive gradient, it's going that way. If it's negative, it's going that way. Okay. All right, let's move on to the second question. All right, this one looks similar to the green one, but don't be fooled by that. Yeah, let's just go through this one again. Let's go through the second one. Look at that. So let's look at we've got our equation. Y equals mx plus c. So where does it cross the y-axis? It doesn't, so that's 0. Okay. What's the gradient? Let's look at the gradient from here. So you know, so you find out. So this is a good way to find out the gradient. So you can pick anything from here. So you can go anything from 1, 2, 3, 4. So I'm going to go from 2 up there. So 2 meets it there, and I want to see where this corresponds on the y-axis. It corresponds to 4. So x equals 2, y equals 4, and the gradient is 2 divided by 4, 2. Because y is always twice as big as x. Okay, so now I can put in here 2. So the equation will look ey equals 2x, and that's it. Because y is always twice the gradient of x. So you can double check that. So when x is 1, y is 2. When x is 2, y is 4. And even if you put it to 6, when x is 3, y would be 6. So that formula is right. Okay. I hope this is making some sense to you. Alright, let's keep on going. This time it's not going to go through. One more thing I want to say. Yeah, no, it's right. Let's go on to this one then. Write down your formula. Y equals mx plus c. So let's see, what does it cross the y-axis? 4. So we know that's 4. Now we need to work out the gradient. Alright, so it crosses the x-axis at 2, minus 2, and it crosses the y-axis at 4. Again, you find the gradient by how many times, what the ratio is between 4 and 2, which is 2, because 2 divided by 4 is 2. So that is 2. Okay, so you get y equals 2x plus 4. Yeah. Alright, let me move on to the next one. Now this one's, you get a couple of these ones. These may seem quite confusing, but not so hard to work out actually. So look in there. Work out C first. C, where does the line cross the y-axis? At 1. Yeah? Easy to see that. Now, what's the gradient? Ask yourself the question, does it cross the x-axis? Which is this line now. No. So nothing and nothing. So all it is y equals 1. All that's saying is that y equals 1. The line is crossing y at the point 1. That's all that's telling you. Okay? Alright. Let's go on to this one. So you notice anything different with this one? And the ones before, the line was going that way. This one, the line's going this way. This should tell you that the gradient, this is a positive gradient. This should tell you that the gradient is now negative because it's going the other way. Okay? So start off by putting your equation on. Y equals mx plus c. Let's find out the c. Where is it across the y-axis? So we're going to follow the pink line here. So it shows us the y-axis, the line crosses the y-axis at 4. Let's work out the gradient. I've done really easy gradients for the time being. They do get a bit more complicated than that, but so how do I find the gradient? So first, look where it crosses the x-axis. 2. Where does it cross the y-axis? 4. 2 divided by 4 gives you the gradient of 2. So yeah. But remember I said this is a negative gradient, so it's not 2x plus 4, otherwise it would be going this way. So it's minus 2x plus 4 equals minus 2x plus 4. Yep. Alright. Yeah. Alright, let's move on to the other one. Again, this is going the other way, so it's telling you that it's a negative gradient. So again, where does it cross the y-axis? 2. The gradient, it crosses the x-axis at 1, and it crosses the y-axis at 2. 1 divided by 2. It tells you that there's twice as much as 1, so that tells you the gradient is 2. Okay? Alright, so that again is y equals minus 2x plus 2. Alright. One small thing I would just say that when you're working out the gradient, you can do 2 ways of doing it. If you already have the coordinates, so if you have a line like this, where it's telling you it's crossing the x-axis at minus 2 and the y-axis at 4, it's quite easy to work out the gradient. Yeah? Because you just divide 4 by 2. Gives you that. But if you don't, if it's something like this, where it doesn't cross, if it doesn't do this or that, if it crosses right through the point of origin here, so there's no value, you can do the other way of getting working out the gradient, which is this. You can go 1, 2, 3, whatever. You can draw. You can imagine that you can draw up your line from here from 2, and see where it crosses the see where it crosses the line, and make sure you put a point in the line and see. So you find out where. So the line. So to work out the gradient there, you can use 2 and just line up there where it touches until it touches the line, and then go at a right angle to the left, and see where it crosses the y-axis, and that you can work out the gradient that way. So if it goes to the point of 0 like this, you can work it out this way. But if it does this, you can work out just with the coordinates, with the scale. Yeah, I hope that makes some sort of sense. I mean, it looks quite easy, but you just need to practice and practice and practice and practice. Yeah, and hopefully you understand that. Okay, all right. Next one we're going to look at is bearings. Get out of this.